Let's see. All right, we're starting. We're live. My name is Bill Kennedy with Arden Studios and Arden Labs. Arden Studios is the contract and consulting side of our business. Arden Labs is the training and community side of our business. So a lot of what we're doing with our Hangouts and our videos and our training is all around our Arden Labs brand. I'm going to switch over to the presentation. I'm going to be talking about error handling in Go. The talk I gave in GothamGo last week. It was an excellent event, a lot of great talks. I learned a lot. And you always know it's a good event when you come back wanting to just refactor a lot of code, And I heard a lot of people saying that after the event at the after party. They all wanted to go home and refactor a lot of code, so that was awesome. So let me switch over to my slide deck here. All right, everybody can see that? They can see what a nightmare. All right.
Yes.
So I got a thumbs up now, up in the world over there. All right. Let's get right to the talk. Since I lost a half an hour on technical difficulties, which I will have to edit out tomorrow. And I apologize for everybody watching live on the YouTube side. But I learned I have to create PDFs for these presentations, or PowerPoint isn't going to have fun. I just put this slide up just because this video is going to be out for a little while. I'm pretty excited about this. We've got some trainings coming out, and I just wanted to share that we're going to be next year in San Francisco, in Denver, in DC, and in New York City. We're going to be in Edmonton in January, and we've got India coming up in February too, big GopherCon event. So it's all really exciting stuff. But this talk tonight is the talk I gave in GothamGo. It's on error handling in Go. So let's get this started. So let me start with a story and how this talk came to be. So one day, Nathan, my friend Nathan, was hanging out. Oh, we lost all that too. Was hanging out in Slack and was asking some questions about some code that he was trying to put together for handling some errors coming out of the I/O package. Now, this isn't the actual code that Nathan was working with, but it's very similar to what he was looking at. And I jumped in a private channel with her. I started just a direct message with him, and I was looking at this code, and it just didn't smell right. And when things in Go look really complicated, usually you're doing it wrong. Go has really gone out of their way to make the language simple to use and simple to read. And so this just smelled really, really bad. What Nathan was trying to do, and again, this isn't the exact code he was using, but he was getting back this error that he knew had a custom error type in it, and he was trying to figure out what the custom error type was so he could determine what he wanted to do next. So this code, when I was looking at this code, and Nathan and I were talking on Slack, I realized that I didn't really understand what errors were in Go. I've been using them, I've been returning errors out, I've been checking for them, I've been doing all this stuff, but if somebody really went to explain to me, like ask me what errors really are in Go, I was completely clueless. So I decided to do an investigation into the language, into the spec, into the language, into the standard library to get a better understanding of what error handling was, what errors were in Go. So I want you to think about a couple of things before we dive deep. The error values that we return from our functions and methods, they should be very specific, and they should be informative. In other words, the caller should be able to get this error and know exactly what the error is and be able to make an informed decision on what to do when that error comes back. There shouldn't be any guesswork. We have a tendency in any language to get an error, just trap it, report it, and a lot of times just shut the program down or just return that back and not deal with it. But we should always be looking for ways to get enough of an error back where we can make a better decision, such as maybe recover from that error, be able to keep the program going and maintain it in a good state at the same time. To me, the purpose of returning errors is to make our software reliable, trustworthy, and most important, respectful to the people that are using our software. There are people that depend on our software every day. If it's crashing all the time, if we don't handle errors appropriately, we're not really being respectful to those people who are using the software. So error handling is more than just this particular thing happened. We want to be specific, we want to be informative, but we want our errors to allow the software we're writing to be both reliable, make the software trustworthy, and most important, respectful. So things that I think about now when I design my functions and my methods that are returning errors. Am I providing enough context to the caller so they can make that informed error handling decision? So I'm looking at that error and I'm asking myself that. I ask myself, this error that I'm going to return, can I use a static message or some simple formatted message? Is that enough? Or do I need a custom type because of the dynamic nature of that error? We're going to see all of this play out now as we investigate more into the language about errors. So let's now go and look at what error values are, how they work, some of the mechanics behind them. Now, Rob Pike said this back at GopherCon back in April. Error values in Go aren't special. They are just values like any other, so you have the entire language at your disposal. That was really interesting when I read that for the first time. Error values in Go aren't special. They're just values. There isn't anything magical about it. It's a value. It's a value that can have any sort of state we want it to have, and it's a value, therefore, it can also have behavior. We can do a lot of things with these error values when we need to. They're not special. So here is just a typical code pattern that we would use every day if you were coding in. Hello? I guess they didn't like me. All right. So I don't know how much they lost, but that wasn't fun. So I'm back?
Yes.
Well, I'm learning a lot tonight. Tonight is a night. All right. Sorry about that. So this is the error interface. It's part of the standard. It's part of the language. And this is what we return when we're returning errors. Values of this error interface type. You can see the error interface has one method associated with it, which is error, and it returns a string. So if you've been working with errors already in Go, you're very familiar with this error type that you've been returning. And now we know that it's an interface. This is the default error type that we use in the standard library. It's called error string. And it is an unexported type. Notice that the first letter is lowercase. And it has a single field called string, whose field is also unexported. So everything about this type, when we create values of this type, everything is unexported. We can't get to it. And then you see the implementation of the error interface for this type using a pointer receiver, and it's just returning the value of the unexported field, S. So this is the default implementation of the error interface, and this concrete type error string is the most used error type that we use in the standard library, and probably most of us in our programs if we've been writing a lot of Go code up till now. And what's really cool is even though this type and the values, the type itself is all unexported, because of the nature of interfaces, the way they work, this type is still really effective in us being able to handle errors and identify when things are right and wrong and get information out of that as well. Now this function here called new comes out of the errors package. And this function is there to help us create error values of that concrete type error string that we saw before. Because it's unexported, we can't create values of that type ourselves. We need to use this new function. And so the new function takes the string, it returns a pointer, an address to that concrete type error string, giving it the text. And what we get back, even though we're returning a pointer of this concrete type, we get back the interface value. Because error string implements that error interface, we're able to get back that error interface value. And so we're working with an error interface value all the time. But notice how new here is actually creating a value of type error string and returning back the address of that out. So it's really cool. And that allows us to be able to use this unexported type as the error and then work with the interface. So just to get an idea of when I'm talking about interfaces here, the box on the left is what an interface value actually looks like. It's a two-word structure. The first word represents the type of value being stored inside the interface, and the second word is a pointer to the value being stored. So when we can think of these interface values, are values that store, an interface value stores a value of a concrete type. And this is how the interface value represents that concrete type underneath. So in our case, the type is an error string pointer, the address pointing to the address of that error string value that we created to the error string. Right? So this is what we're dealing with when we're dealing with these error values, these error interface type values. Now, a lot of times you see in functions the use of returning nil for that error interface value. What we're actually getting back, and we will always get back when we're dealing with interfaces, is an interface value like this. We're always getting back that two-word structure. We're not getting back this one-word structure that's nil. We're getting this. And so in the cases when we're returning nil back, this is what that interface value looks like. The type is nil, and the pointer is nil. And that's what we're handling when we return nil for the error value. So if you look at that if statement, if error doesn't equal nil, that error is checking against a value that looks like this. Now sometimes you have a message that you want to use for a string that you want to use for your error value. The new function just accepted a string. In the FUMP package, there's an error f function that will allow you also to create a formatted string. If you notice what that function is using, it's using the errors.new function underneath. And so that errors.new function is the mechanism to create these default error values that are provided to us by the standard library. So now that we understand what an error interface value is, we know what it looks like, we know how to create error interface values from the standard library using that new function. I wanted to see how this was used inside the standard library so I could better create my packages, my functions, in an idiomatic way, the same way that the standard library is doing it. So when I looked in the buff.io package, I started to notice, in another package as well, but here in the buff.io package, that there were these error variables. Notice that they all start with ERR. But look what this package is doing. It's creating variables of the error interface type with these pre-canned messages already. This is really cool because now, because we have these error interface variables, I can use those in my logic when I get the error back. So look at this. The peek function returned the error value back, that error interface value. And now I put that into, I check if it's not nil. If it's not nil, we know we got a problem. But by just checking that it's not nil, I don't really know what the problem is. I just know we have a problem. But now, because these error variables have been exported with the package, look at this. I can use those in this switch case statement. So not only now do I know I have a problem, I know exactly what problem I have.
Is this more like an application code? Because it seems like, at least in my experience, that when I'm making like a package for the community, that I kind of want to, in most cases, want to forward the underlying error unless it wouldn't make sense in their context, and so they can handle different cases.
Let me leave that for the end. So here what we're seeing is that I'm able to take these error variables and use them to make a more informed decision about what I want to do with this particular error. Here's the I/O package. Look, the I/O package is doing the same thing. Look at all of these error variables that have been declared and exported out of the I/O package. Okay? The one that really caught my eye was the EOF one, because if you've used the I/O package, you've used the EOF value. It's kind of funny, but I never really realized that the EOF was an error variable at the end of the day, not in the way that you kind of use it. Now when I look back at the code, I go, oh yeah, duh, I'm getting this thing back and it's an error and I'm checking it. But this is how it's really worked. The EOF variable is an error variable with the string EOF. So this is really good when our message, when our messages, that error message is static. We can create these error variables. We can export them. We can do this in our own packages to help the people that are using our packages be able to get that error, identify it, but then know exactly what error we were really returning. Here's the read at least function from the I/O package. Notice how the package is returning those error variables as well. So that's the key. Your functions and methods have to return those error variables in order for the caller to be able to use that same error variable to compare and check. And here as well, internally, this function is using the EOF variable to do its own logic as well. That's really cool. So when you need to make a decision about a specific error, check to see if that function or method you're using returns an error interface variable. It's really easy to go out and onto Google and go to the Go docs for any standard library call and go in there and go, oh, this is going to return an error. I really need to know what type of error is coming back. Oh, look, they're returning error variables. Awesome. I can now check those error variables in my logic, and it's not just a matter of there was an error. There was an error, and this was the error that occurred. Now, sometimes we just can't use static messages. There's not enough context there. We're doing something very dynamic. And so we need something a little bit more than just the default error value. So in the net package, there's this special custom error type called op error. This is a really cool custom error type in the net package. Notice what this custom type is doing. It's taking an error that it's getting back from other calls that it's making, and it's adding to it other contexts associated with the call that you made. When I used to write custom errors back before Go and in .NET and in C and C++, I always had heartburn because once I started creating custom error types, it seemed like I started creating lots of them. And when I first came to Go, I still had that baggage. People would say custom error type, and I would go, no, they're bad. Just use the default error type. Just use it. But as I started to study to see how the standard library started using custom error types, I realized that if we use them in a couple of very special ways and don't abuse it, they can be really powerful. So this is one of them. So whenever we're making some network calls, we could get this op error back as the concrete type for the error interface value. And notice again that we're getting some other error, but then there's context associated with that error, opnet in the address. Here's the implementation of the error interface for that op error type. Notice how what we're going to be getting back in that string is fairly complex. It's really dynamic, right? It's leveraging all of the context associated with that type. So this is definitely not a static message. It's a message that can change depending on a whole bunch of different things that we're doing, even down to the machine that we're on. But you can see how all of that state associated with the op error type is used in forming this message. Then I looked over into the JSON package, and I found another set of custom error types, but being used completely in a different way. The JSON package doesn't call into other packages like the net package does. And so on the net package, the methods and functions we're calling may be calling into other functions and other methods. And so that error that comes back could be coming from any of those other dependencies. And so they took that error and they wrapped it around the context for the network call. But JSON is a package that it produces all of the error messaging that you're ever going to get. It's all internal. But at the same time, there's context associated with every unmarshal call, depending on the value, the types, the JSON document that you have. All of that is really dynamic. And so what the JSON package did is they created these custom error types where the type itself was the context. See, before the context were those fields associated with the error. But in this case, the context is the type itself. This custom error type is unmarshal type error. This is the concrete type for an error when we have an unmarshal problem. And also because it's context oriented, we have the value that we were trying to unmarshal and the type we were trying to unmarshal it into. So all of this is associated with this custom type. Here's the implementation of the error interface for this custom type. Notice again, it's a very dynamic string that's leveraging the context associated with the type. Here's another custom type in the JSON package, invalid unmarshal error. Again, this is a custom type the type itself is the context for the error. In this case, this type is used anytime you pass a value into an unmarshal function that's an invalid parameter. And so we have a custom error type that says, we tried to perform this unmarshal against this field and this type, and it was invalid. So we're going to use this type. This is a case where I passed in an invalid parameter, and we're going to use this type. So the type itself, again, is the context for the error. And here's the implementation of the error interface, again, using the context associated with the type. And we get this very rich, context-rich message coming out of the error interface. And so when you can use a static message, a simple static string, or a simple formatted string, and you can create error variables around that as well, you really should do that. That can add a lot of context. It's very simple. And if it gives you everything you need, it's a good practice. But sometimes, like we saw in the net package and the JSON package, that's not enough. And in this case, we want to then create these custom error types to give us that context beyond what those default values can give. Remember, it's all about giving the caller enough information, the right information, specific information, so they can make a more informed decision on how to handle that error. That's what it's all about. So we're looking at this and we're going, can the default error type be used to give that caller enough information to make an informed decision? Can I expose a variable that will give them the ability to do that? Or do I need a custom type, because things are very dynamic here? But it's always about the caller, the person that's going to be making a call to that function and having to handle that error. That's what we have to focus around. Now, it's nice that we can use these concrete types as the context for the error, but remember, what we're handling here are not concrete types. We're handling an error interface type, an error interface value that's storing the concrete type underneath. And so, unless we can identify what the concrete type is and convert that back into the concrete type, then it really doesn't help us to have these concrete types as the context. So there is a way to be able to take this error interface value, identify what concrete type is inside it, so we can make that more informed decision coming out. So this function is called unmarshal. It's an unexported function from the JSON package. In fact, the exported unmarshal function calls this function internally. And I'm showing this to you because I want you to see something that's really interesting. If you look at the first return inside that if, unmarshal is returning an error value of type invalid unmarshal error. here's the context. We talked about what the context is around this error. Again, the return type is the error interface, right? So we're going to create a value of type invalid unmarshal error. We're going to return a pointer of that out. We're going to get that error interface value, but the concrete type underneath is going to be based on this type. But if we look at the return at the bottom, it's returning the value of saved error, which is an error interface value. What's really interesting is if you peek deeper into the code, there are several different types that can be, several different error values of different concrete types that can be stored in saved error. So basically, when you call unmarshal, you can get back several different error values with different concrete types underneath. This is an example of how that's possible. So one way to be able to identify, one way, not really the best way, but one way to be able to identify what the concrete type is through this syntax. And so we take the error interface error value, and we use this interface conversion syntax, and we say, okay, let's convert this to a pointer of type unmarshal type error in the JSON package. Now, either OK is going to be true or false. If OK is true, then life was good. If OK was false, then the concrete type wasn't this type. So this is one way to do it. It's really not the best way, but it shows you a way of being able to identify, not only get the value of the concrete type, but also validate that it is of that value. This is a better way. There's special syntax that we can apply in the switch statement that makes this code so much cleaner. So in the switch, we're able to say error dot, and then in that same parenthesis syntax, we use the keyword type. Now what's nice too is we can bound that into an assignment using the short variable declaration operator. And so we've got two things here that made the code really clean. The value of E, if that is the type, will be the concrete value that that interface value is storing. And so now we have the value of the concrete type. And then we can use the case statements to do that check. So if it is a pointer of the unmarshal type error, then I know that E is already that, and we can use it. Case, it's an invalid unmarshal error. E is now already of that type, and we can use it. And so this still doesn't look right. This is kind of where Nathan and I we started from. This was where we started. And this code just didn't smell right. When code doesn't smell right in Go, most likely it isn't right. And there's an easier way to do things. And from here, we figured out this syntax. And this is really clean. It makes sense in terms of being able to identify, I've got this error interface value, which concrete type is underneath. Now I know I have the value of that, and now I can leverage all of that state, all of that other context inside that error interface value very, very cleanly. So some of the things that I learned during all of this research around how errors work. Errors are just values. They aren't special. We can put any type of state we want in them. We can put any type of behavior in them as well. We can do a lot with our error values. The default error value is the most used in the standard library. And many packages in the standard library actually provide error variables. So you should look for those and see if they're there. And the standard library tends to use custom error types from what I saw when the context that they need to deal with goes beyond that default error value, when it goes beyond that simple message. There's more to that. When that error occurs, there's more to it than just a message. So again, use that default error value as that first choice, especially when it provides enough context for the caller, because again, it's always about the caller. We're building APIs, so our code is reliable, it's trustworthy, and so we're being respectful to everybody who's using it. Okay? Provide error variables in your own packages when you're thinking about errors. So if you're going to be dealing with the default error type, provide those error variables, use them, and return them out. And only use the custom error types when you need that extra context beyond the default error value. Okay? Again, we want to give the caller the best possible opportunity to make the right error handling decision. That's my talk. All right, guys, so that's the talk. We're going to open up some questions. I know you had a question.
Yeah, so my question was about how deep should you go when you're checking for the different error types in module code versus application code. Because my example is like, okay, let's say I have a module that interacts with the file system and interacts with the database. So if something in the file system fails, it's going to give me a certain subset of errors, right? And if something in the database fails, it's going to give me a certain subset of errors. And so normally what I would do in my own modules is that I just forward those errors and then have the application figure out, oh, well, okay, if they care, for specific errors, oh, well, this is a file system error versus this is a database error. So I guess my question is, when should you delegate that to the application layer, and when should you do that in your
So the question is, as these errors are being produced, as your code is running, when do you just decide that this is an application, a user issue that the user has to really interact with, as opposed to something you can interact with, right? And I'm going to go back to the one thing that I tried to say. It's really easy to just take the lazy way out and just say, this error occurred, okay, let's just log it and let's terminate the program, right? But if our phone systems did that all the time, think of the phone, we don't have landlines as much as we used to, right? But I love the PBXs. How many times were you on a landline and that phone went down? It was incredibly rare. And it wasn't because those engineers didn't have bugs. Because it was written in Erlang, thanks. It wasn't because those PBXs, okay, and a lot of your networking equipment, you don't think the routers and the switches have bugs? They do. They've got bugs. But when a bug occurs, they don't just give up and shut down. They find ways to recover, to keep those systems running. And so that's, I think, what you have to ask yourself. This error occurred at this moment in time in this piece of code. If the person who wrote that method or function gave you enough context so you can make a decision, this is something I can recover from if I do this now, then I would want to recover from it. I don't want it to go all the way back to the user and have the user feel, oh my God, I now have to get involved in order to keep this thing moving, right? Now, there may be a small, you might hear a little blurb, you might miss a word, but you forget about that, you just kept going. And so I think you want to, as soon as you can, recover from those errors and keep the system going as far down as you can. Sometimes you can't, sometimes it's got to go all the way up because you don't have enough context to make the right decision. So I always think it's about context. And when you're building your packages and your functions, your APIs, think about every single person who's going to make that call. Can I give them the right amount of context so depending on what they're trying to build, they can make this error recoverable. They can recover from this point. I think that's what you need to focus on. And Go, because errors in Go are just values, you can do that. And not only just give them state information, but you can also add behavior to those error values to even help them do more and make it easier for them to make those decisions. Yeah.
You want to just an example for this? For instance, when you use IO copy, like your weight is eventually going to fail with an EOF. So IO copy, just check for IOF.
You guys have questions?
And then it goes through anything that's not EOF, it just goes down to the cover. So like if you post something and you want to under some situation, you just check for some errors, and if you don't want to check for everything that's not.
Guillaume is explaining in the IO copy package how what I said could be applied based on how the IO package is built in returning errors. Really wasn't a question. You guys have any questions on the Hangout? No? Todd, no? All right, yeah, you have a question? This is going to be good because it's from Guillaume. So I got to brace myself.
Have you ever looked at the OS error management, the package, the OS package, with things like OS.is not exist, or is not exist?
So he's asking me if I've looked in the OS package and have seen, are those variables or a function that's called is not exists.
And this kind of
No, I've not seen that function. There is so much to error handling too that I kind of gave you a broad surface. I mean, I could go into functions and I can go into methods and I can get into other details.
it's a legacy bad.
Write that again.
It's a legacy bad way to handle errors.
Or bad way to handle. Yeah, I don't use special functions to check errors. That's what you're saying. Yeah, don't do that.
But the standard way doesn't.
I think, Jack, ask your question again because I missed it. And it was in the OS package. Oh, I thought one of these guys asked a question, but I can't see it anymore. Let me see, maybe it's here. No. All right. Oh, wait, I think it was. Oh, all right. Oh, here it is. What is the recommended practice? Should we create type variables with multiple errors like we do in C++ with enum description? So these questions are always difficult to answer. So what I'm going to say to you is, I want you to treat Go very situationally. I don't want you to ever say, this is a pattern that I've used before, and I'm going to apply it blindly to everything that I'm doing in Go. I want you to look at every situation and go, what is the best way to handle this particular situation? And you're going to find that this idea of these patterns that we reuse over and over again aren't always the best way to go in Go. And so I want you to go back to what I said. I've got this function. It's got to return an error. There could be different types of errors. It could be different contexts. What is the best way to give the caller the right information? It might be a custom type. It might not. I'd like you to ask, can I use the default type first? Can I create that error variable? Can I do it with a static string? If I can, done. Do it, static string, error variable. They can check it with the if or an else, and life is really good. It's simple. You didn't have to create any new types. But you might just turn around and go, that's not enough here. All right, now invest some time, create that type, and return that out. All right? So that's my recommendation there. And don't get into the pattern that I fell into in C++ and C#, where it was like, okay, I'm going to create an error type. And we don't have classes in Go, thank God, but it's very common in an object-oriented programming language to go, okay, I'm going to create a custom error type for every class. And when I call this method from this class, it's always going to be this custom error type for this class. First of all, it's incredibly difficult to manage, and it really doesn't add the value that you think it's going to add in terms of context. It actually makes things more complicated for everybody. Right. So we want to be really specific about the errors, making everything reliable, trustworthy, and informative. All right. Anybody else have any other questions? Yeah.
So maybe I missed this in the last examples when you were doing the custom structures, the errors, like the messages, like the messages that you get back as part of the structure. Are those regular strings or are those like error string types? And should they be error string types?
So it was asking the actual error messages that you would get back from an interface error. Are those strings or error types? So if we went back and looked at the error interface itself, the method was error and it returned a string. And so when you are saying error.error, the error method, you're getting back that string. That's the return type. The printf is leveraging reflection to know that at that point we want to use that error, right? That error message. And that's why you're dealing with the string. And so that's really dangerous if you're going to compare strings. Because what if you decide, well, every time I use this error value, I'm going to use the error method, and I'm going to get the string, and I'm going to compare that string. And then the package designer decides to change something, even just as simple as everything was in uppercase and now it's in lowercase. This has happened to people. The error message didn't change, but they didn't like the case. There was a typo. And now you go get that new package, and the whole thing starts to stop working, right? That's where that error variable comes in. Because then that package designer could have just changed the string in the error variable. You're using the error variable. That doesn't change, right? That's really cool. So if you see yourself going, okay, I'm going to compare the string here and there, that's bad, right? That's a bad smell. Now, if the package designer who designed that function and method didn't give you the error interface value, didn't give you any way to identify specifically what that error is, and now you've got to look at the string, well, shame on them. Shame on them, right? They didn't do their job. They didn't give you the opportunity to write the software the best way you could. And you can't, by the way, you can't go ahead and just create your own error variables. That will not work. Remember, we're comparing the value inside that interface value. So it has to be the same error interface that is being returned that you're checking. You can't go create your own and do that. They will not be compatible. All right? Primarily because with the error interface type, what are we storing as the concrete type for that error interface value? Remember, we have the type, and then we have a pointer, the address to the error value. The implementation of the implementation of the error interface using a pointer receiver was very specific. They did that very specific. So you couldn't create your own error variables and compare them. Why? Because at that point, what you're comparing is the address of the error, the error type that was the default error type that was created. So if you create your own error variables, you're going to have your own address there. If they used a receiver, a value receiver, and not a pointer receiver, then you could have created your own error types. Because now addresses wouldn't have been compared, the strings would have been compared. And that would have created a lot of chaos. And so when you go back and you look at the implementation of the error interface for that error string type, the pointer receiver there was deliberate, was absolutely deliberate. So the addresses are being compared. So when you say error doesn't equal this error variable, the address, the value of the concrete type is what's being compared. All right? Very cool stuff. All right. All right. Function 1 calls function 2, and function 2 calls function 3. Function 3 returns an error. Okay, it can happen.
But I mean, is this the normal practice? Or in this case, if it's my package and I have like 10 functions down, they panic and then just kind of catch some.
First of all, you now get flogged for saying if you should panic. We never, ever, 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 ever throw panic in our code.
If I 10 functions down, so all I have to do is just bubble up.
So if you're 10 functions down, I want to go back and give you the same answer I gave Nizar. Okay? I want you to find a way, when you can, to recover from that error as soon as possible. So if you're 10 layers deep and you go back 2, and in that 8th layer, there's an opportunity to not bubble this up anymore, to recover and keep the program running in a good state. That's what you want to do, right? You want to keep this program running. You want it to finish. You want it to be reliable. You don't want your users to know that all these things happened. You want to try to recover. And so the further down you can recover, the better that experience is going to be all the way out. But you can only recover if you have enough context, if you have enough information. And that's what I'm saying as you as package writers, when you're building your own methods and functions, even for yourself, think about if this errors, who's calling it, and is there enough information there so it's not just necessarily a trap and return. Can I do something more? Sometimes you can't. But sometimes you can, and you ignore that. You just think, oh, I'm just going to pass it all the way up and deal with it. You never consider the possibility that it could be recovered here and still maintain a good state and keep the program going. Let it finish. There's lots of processes where you could let it finish and maybe just report the errors later on. Let's say you were inserting tens of thousands of records, right? And a 2 or 3 failed. Well, are we going to shut down the entire program because this one happened to fail 5 records in? Maybe. But if it's not where all of these necessarily are in a transaction, wouldn't it be nice to get all of them in but these 3 and to keep going? And then we can build some process that comes back in and tries those 3 again. Right? And you can do that if the error message is that you're getting back from that call is coming back. You know, if you're getting a socket message on that database call, maybe that's bad. But if you're getting some sort of index error or something more like that, you know the next one has the chance of going in, right? And so it's a matter of, is there an opportunity to keep going? Is there an opportunity to recover? Is there an opportunity when it's all done to then maybe report what's happening and go back? It's all situational. You have to look at it. But it all starts with the error value. The error, it all starts and ends there. If the error value isn't giving you enough context, if you don't have the ability to make those decisions from that error, then it doesn't matter at all. All right? Bye, guys. That's it. Hey, thank you for joining us here. I got some editing to do now after the half an hour debacle. But we'll get it. So thanks, guys.